You're probably familiar with the old computer game Minesweeper, but I know what you're thinking. Is there any way to play this game in class on my calculator? Yes, you can. Hi, I'm Aiden, and today I'm going to show you how to code Minesweeper on the TI-84 Plus calculator. Let's get started. So this game is actually something that I programmed about half a year ago. It uses two programs, one called Minesweeper and one called Z Minesweep. The Z denotes that it's a sub-program of the first one, and it starts with a Z so that it's alphabetized last on your list of programs. What this program does is draws the numbers 1 through 8 and the bombs, and it needs to do this in a custom code because all the numbers have their own designs to make them fit in the small tiles of the grid. And it's used twice in the main program, so it is worth having an entirely second program to run this. And so I'll do a little showcase of the game now. Both of these programs will be on my website, which will be in a link in the description. You can see here it's called Minesweeper. And when you run it, it'll ask for the difficulty, which will be 1 through 3. This will determine how many bombs are going to be placed in the map. So I'm going to choose 2 because it's the middle one. It'll be a regular amount of bombs, which ranges somewhere between 20 and 40. It's usually around 30. So you'll see the first thing it does is draw the grid, and then it says placing bombs. What this does is it's running an algorithm. It's going through and it's placing bombs in a way that they are clumped. Because if you see on a real Minesweeper board, the bombs are always clumped together. They're not randomly spread out because you want large open spaces with no bombs. The next part is numbering tiles. Once the bombs are placed, it goes around and counts how many bombs are around each tile and puts a number there. And the last section is called changing bounds. All that does is change a matrix in the code to make it use less space once the code is done. If you were to escape the code before it finished. So the way this works is that you can move around with the arrow keys, and enter opens a tile. The first tile that your cursor always lands on will always be open in the code. And so it opened a 1, which means that one of these tiles around this 1 will have a bomb in it. And to put a flag down, you press the plus key, and to remove it, you delete it. And so I'm going to guess that this one doesn't have a bomb. Okay, it's another 1. I'll go here, another 1, another 1. And now we've hit an open space, which is pretty much a 0. That means that all of these spaces around it are guaranteed to not have a bomb in it. Now in normal Minesweeper, if you hit this space, it would open up a large space immediately for you. But because of the capabilities of the calculator, it cannot do that, and you have to open it manually. So, for example, I'll keep opening these squares, and we'll see where we can guarantee that there's a bomb, which will definitely be here. This is the only space around that 1, so we know there's a bomb there. Now, let's say, for instance, you did hit a bomb. Let's just guess this one. Okay, so there's definitely a bomb here then. Let's see what happens. So I've clicked the bomb, and the bomb appears now, and now it's just uncovering all of the other tiles. So we can see what a normal map looks like. You can see already that there are large spaces, and then there are clumps of bombs. And we get numbers, 1, 2, 3s. There's even a 4 and a 5 on this one, which is sometimes rare. A 5 is pretty rare. And lastly, you'll see this is how many flags we are able to put down, also correlating to how many bombs are on the final grid. You can put down 23 flags, and the game won't end if you put them in the wrong spot. The game only ends once you have uncovered every tile that is not a bomb. And this last number that was moving up is just pretty much a timer. It doesn't have the interval of actually a second. It just moves up in general, so you can keep a score to test against yourself later. But you can see the algorithm made the bombs fairly clumped. It's doing a good job, and it's got pretty open spaces. So we've seen what it's like to lose, and I'll do a time lapse of a full game at the end where the game is successful and I win the game. But right now, I'll walk through the code on how this program works. The first part of the main code is your pretty standard stuff. Turning the axes off, clearing the graph, turning the function off, and then setting the coordinate system so that 0, 0 is in the bottom left, and each pixel is 1 unit. The next part is asking for the difficulty. D can be 1 through 3, and then it changes D to be a slightly different number so that D is used later to calculate the odds of a bomb being placed in one tile. The next part is drawing the game board, which is just a bunch of horizontal and vertical lines. And then the next 3 main sections are placing bombs, numbering tiles, and changing the bounds. And I'm going to show you real quick how it actually does that. So the first thing it does is it makes a matrix 13 by 20. But you may have noticed that the game board is not 13 by 20. It's actually 11 by 18. But the reason we need this extra gap around is because when the game is placing bombs, it uses other bombs that have already been placed previously to determine the odds of the next bomb being placed. So when we're looking at this tile, and if it's placing bombs top left, then going right, down a row, left to right, the only bombs that could have been already placed are in these 4 tiles right here. So every time a bomb is placed, it needs to look left, up, and up right to see if there are bombs in those 4 tiles, and if there are a lot of bombs in those tiles, then it's going to have a higher likelihood of placing a bomb here. So the problem is, and the reason why we need a row and a column going around the whole matrix, is that if you're trying to place a bomb on a tile that is either at the left edge of the matrix or at the top edge of the matrix, those tiles don't exist. So we need an extra gap of 1 around the whole matrix, just filled with zeros, so that the program does not run an error. And then obviously, lastly, it goes around and places numbers in all the spaces, and it just, for each of them, it just goes left to right and then down. And it just counts, if we're looking at this tile, it's going to look at all of these right here. And then it's going to say, well, there's 2 bombs, let's put a 2 there. And then the very last section, changing bounds, it just removes that extra gap around the whole matrix so that if the program was ended early, it would be taking up less space. You technically wouldn't need to remove that gap for the game to still work, but it'd be taking up less data if you removed it. So back to the code. First, it makes that 13 by 20 matrix, and then it goes through all the tiles, and E is the number of bombs in those 4 tiles, left, up, and right. And it just, each of them, it looks at it and says, if there's a bomb, which is denoted by the number 9 in this case, it's going to add 1 to E. And then here is where it calculates the odds of a bomb. So it's going to generate a random number 1 through 10 minus D minus E. So you'll see if D was a high number, like, if your difficulty was 3, then this number is going to be less. And if there are even more bombs in those tiles, then that number is going to be even less. And so at max difficulty with 4 bombs being around those tiles, it's going to be, your random integer is between 1 and 2, which means there's a 50% chance of a bomb being placed in that tile, which means that for any given tile, the maximum odds that a bomb is going to be placed in that tile is 50%. And then once it generates a number, it says, are we going to place a bomb there, yes or no? And then at the end, it's going to clear the text that says placing bombs, and then start the next section, numbering tiles, which does the exact same thing, moving top left to bottom right. But this time it actually needs to check all the tiles around it so that it can number all the bombs correctly, because it actually needs to check all 8 tiles around it instead of just the left, up, and right. And then it removes that text again, starts the next section, changing bounds. It shrinks the dimensions of the matrix by 1, and then shifts all the numbers up left, and then shrinks it by 1 again. And then the last section last section before the game starts is starting where your cursor is going to be, drawing the cursor. And then this is, it counted how many bombs were being placed, and F is for flags, or how many bombs are in the game. And then it's going to put that number on the screen. Here's the main part of the game, which is actually getting the keystrokes and the playing mechanics. And first it calculates how many tiles are not bombs, which is 198, the max tiles, minus F, the number of flags, aka bombs, and that's Z, so that's how many tiles left. And once W, which is how many tiles you have opened, equals Z, the game ends and you win. Or the game can end prematurely by you opening a bomb. And so first it gets your keystroke, and it also adds a little bit to this timer every round that it asks for the keystroke. And then keys 23 through 35 are the arrow keys. And it's a simple movement mechanic where it's going to change the pixels where your cursor are, calculate the new location of your cursor, and then change where your cursor is going to be, and then change your location. And then K equals 95 is the plus button. That's the placement of a flag. K equals 23 is the delete button. That's deleting the flag. And then K105 is where a lot of stuff happens. That's the enter button. So first it needs to check, can this tile actually be opened? Has it already been opened? And then, if you can open it, it runs the other sub program, which checks first, is this a flag that you've already placed down? Because if you enter a tile that there's a flag on, it wants to remove that flag. And so, and then it gives you the flag back. And then it opens the tile and then checks where you are. And then depending on what number is in the matrix that was calculated earlier, it's just going to draw that number. And each of these numbers have a custom sprite pretty much. And so it uses up a lot of data here. And that's why it's a sub-program. And if 9, which is the number for a bomb, is what is uncovered, it's going to uncover it, draw the bomb, but then 11 equals K, which is what's next. 11 equals K is also the Y equals button, which is pretty much an end button. So if that button is clicked, it's going to uncover stuff and then go through the whole board and start uncovering the bombs. And then at the end of it, it's just going to stop the whole program and delete the matrix. And so that's what this part does. And the very last step, if you do complete and leave the repeat loop, it's going to give you the text win, and then turn your cursor off, and then wait for you to, it's going to pause for a second until you click enter, and then the program is going to shut down, and it's going to delete the A matrix. So that's how the program runs, and you can see it actually does make some pretty good game boards. These are some game boards that were generated. They're in the difficulties 1, 2, and 3, but they're not ordered on this in this picture at all. But you can see that the bombs are clumped very well. The algorithm that clumps the bombs does work fairly well. You can even see here we have a 7, but most of the time it's 0, 1, 2, or 3. And there are also often some 4s. So that's how the program runs. Once again, both the program and the sub-program are going to be on my website, which will be in a link in the description. And I will run a time lapse of the full game now. All right, I just beat the game. It was a pretty difficult board, and it actually took me a lot of tries to actually win this game. But that's the end of the tutorial. Thank you for watching, and I'll see you guys next time.